Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think yesterday we have discussed about the multiple choice question or the objective type question, because we are facing the COVID-19, and so due to that pandemic, all the university examination as well as continuous internal assessment will be carried out on online mode, and due to this reason we are discussing the multiple choice question, how to solve, how to choose the correct option from the following. That overall discussion as well as strict behind how you can select the correct alternative from the four options are given from it, how you can select properly. That type of the discussion we had discussed yesterday, because we are discussing the multiple choice question based on polynuclear and the heteronuclear aromatic compound, and what kind of the nature of that multiple choice question or the objective type of questions, and how you can able to choose the correct one, that I am trying to explain here. So let's see today the remaining questions which are based on this topic, polynuclear and the heteronuclear aromatic compounds. So let us start with that. Question number 13, Huckel's rule is related to. Four options are given. Huckel's rule is related to acidity, basicity, aromaticity, unsaturation. As we know that those organic compounds obeying Huckel's rule or following Huckel's rule, that compound are known as aromatic compound, whether they are homonuclear or the heteronuclear, but they are obeying as a Huckel's rule, and that's why, and that Huckel rule is related to as a aromaticity, fully conjugated, planar and cyclic system obeys containing 4n plus 2 pi electrons are known as Huckel's rule, and therefore that Huckel rule is correlated with that aromatic, and therefore the correct answer would be C over here. Remember this, aromaticity, that is the right answer. Now let us move on to the question number 14. Same 4n plus 2 pi electrons formula was first discovered by, first invented by, discovered or invented, or who first told that equation. You have to remember the name of that scientist. Look at here, Wundt, Huckel, Holar and Berzelius. These are the different scientists' name, but out of that four, which one formulated formula 4n plus 2 pi electrons? Because at the beginning or in this question, Huckel's rule. So Huckel rule is nothing but containing as a 4n plus 2 pi electrons are known as a Huckel's rule, and therefore the second option would be the correct answer that you should remember over here. So now move on to the next question. The next question would be, let's see here, question number 15 now here. Let us see question number 15. I am trying to justify the answer why we are choosing as a correct answer that one. I am trying to give the justification regarding this. So now is the question number 15. What is it? See here. Question number, naphthalene contains number of pi electrons. Naphthalene contains how many number of naphthalene contains how many number of pi electrons? How many number of pi electrons? Look at the nature. How many number of pi electron contain or have naphthalene, or the nature of naphthalene contains how many number of pi electrons. You have to count how many, means you have to give the correct number of pi electrons. Let's see here. There are options are given, and options are like this. 6B is 10, C 14, and D is a 12. So what do you think, which would be the correct answer? 4 options are given, 4 alternatives are given. Out of that 4 alternative, you have to choose the correct alternative from the following, or tick mark the correct of the following. So first of all, I am justifying it why the correct answer would be here, that we are finding by knowing the structure of naphthalene. See, this is the structure of naphthalene, and this is a pi bond. Look at this, is called as a carbon-carbon double bond, is called as a pi bond. How many pi bonds are there? One pi bond contains 2 electrons. Remember, one pi bond contains 2 electrons. So you have to count number of pi bonds present over here. 1, 2, 3, 4, 5. 5 pi bonds, and therefore number of electrons are 10. Remember here, number of electrons are 10. See the options, B is the correct one. So in this way, you have to confirm, you have to justify on your own. Then you will get whatever it is. Suppose 1 mark question, so you will get as 1 mark. 2 mark question, you will get the 2 mark. But it's so easy. But one should know the structure of the naphthalene, and you must know again, one pi bond is contained as a 2 electrons. One pi bond means 2 electrons, and therefore one pi bond contains 2 electrons, therefore pi bond is nothing but as a 10 electron. You have to multiply by 2, so 5 into 2 you will get as a 10. So that's the answer. Now let us look at the next multiple choice question. We are discussing question number 16 over here, and the question number 16 would be, naphthalene molecule has planar structure and contain the pi electrons in dash 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 dash. Let us see. Naphthalene molecule has a planar structure. Naphthalene molecule has planar structure. Naphthalene has planar structure and contains the pi electrons in and contains the pi electrons in dash dash dash. And the options are: A option would be p orbitals, B option would be sp2 hybrid orbitals, C would be s orbitals, and D would be none of these. Look at once again. Naphthalene molecule has a planar structure and contains the pi electrons in dash dash orbitals. We can say here whether they are present, and we know that atomic orbitals, there are 4 atomic orbitals, and which are s orbital, p orbital, d orbital and the f orbital. These are the different atomic orbitals, but in case of the carbon atoms there is a hypothetical orbitals are used, that concept, but it is very useful as far as the organic chemist point of view is concerned. And therefore hybrid orbitals means combination, hybridization. You might be knowing, most of you are knowing hybridization. Hybridization is nothing but as the process of mixing and recasting of atomic orbital of different energy which is overlap to form the new orbital, and that orbital is called as a hybrid orbital, and that process is known as a hybridization. So on the basis of that hybridization, different orbitals are combined and to form as a new orbital which is equal in energy and which has the fixed direction. It can along overlap with the fixed direction. It has a fixed geometry, because all the organic molecule, the physical properties are as well as chemical properties are depend upon its molecular geometry. And therefore here you know that the structure of naphthalene, you know that this is the structure of naphthalene, and when this carbon-carbon double bond is formed, that acquires the planar structure, that is the sp2 hybridization. This is the sp, 1 s orbital and 2 p orbital are combined to, by overlapping we are getting as a new orbital, that is sp, and which is triangular in nature like this. This would be the structure of this sp2 orbital, which is a planar in nature, and this is known as a sp, 1 s orbital and 2 p orbital combined together, and we are getting as a, these are trigonal geometry, and there is a sp2 hybridization, and bond angle will be 120, and bond length is found to be if there is a open only as a carbon-carbon double bond, if consider it is has 1.34 angstrom. That is a bond length found in the carbon-carbon double bond. This is just for your information. But here, so look at here, naphthalene, every carbon atom involving as a double bond, and therefore each carbon atom in naphthalene has the sp2 hybrid orbitals, and therefore the right answer would be here is a sp2. So in this way, with the justification, most of you knowing why I am choosing as an alternative that B, sp2 hybrid orbital, their justification just now I have explained over here. Now this would be the question number 16. Let us see the question number, multiple choice question number 17 over here. Now let's see the question number 17. Question number 17. Let's see what is it. Naphthalene on reaction with acetyl chloride in presence of AlCl3 and CH2 gives naphthalene on reaction with naphthalene on reaction with acetyl chloride in presence of AlCl3 and CH2 carbon disulfide, CO2 we are calling it as carbon dioxide, here is a carbon disulfide, this one gives a delta dash, and the answers are given over here. One would be 1 acetyl naphthalene, 1 acetyl naphthalene, 1 acetyl naphthalene. B would be 1 2 diacetyl naphthalene, and C would be 2 acetyl naphthalene, and D would be all of these. Now once again look at here carefully. Naphthalene on reaction with acetyl chloride in presence of AlCl3 and CH2 gives what it gives. If you know the reaction, then you can able to choose the correct answer. This is the naphthalene when it is treated with CH3 C double bond OCl in presence of AlCl3, which is one of the famous reaction as we know that. But here the solvent plays an important role. If you change the solvent, the product would be different. So here, even though it is a Friedel-Crafts alkylation reaction, as we know that, and generally at the beginning while studying the general, making as a general statement regarding as a naphthalene related to electrophilic substitution reaction, we generally made a statement like that Naphthalene undergoes electrophilic substitution exclusively or preferentially at one position. That is a general statement, but every general statement has an exception, and now the exception is differentiated or due to the solvent playing an important role over here, and due to that we are getting the different products. Now when we are using as this type of the solvent, the resulting compound generally exclusively gives the product you can see here, acetyl group will be present at one position exclusively. This is the major product given by this Friedel-Crafts acylation reaction when it is treated in presence of carbon disulfide. Look at here, is there any, when you know the structure, this 1-acetyl naphthalene, and this is nothing but as a name of this compound, 1-acetyl naphthalene is the name of this compound. Now 1,2-diacetyl naphthalene, so the structure I am showing you over here. You can see at one position C double bond O CH3, at two position C double bond O CH3, and 2-acetyl naphthalene, the structure which I am showing you over here. So you can clearly see here, two position C double bond O CH3, and all of this. Now look at here, only exclusively in presence of CH2 we are getting only 1-acetyl naphthalene. That is the correct answer, and that we have seen over here. And the same question I am repeating over here, the question number 18 now here. Question number 18. Naphthalene on reaction with acetyl chloride in presence of AlCl3, aluminum chloride, in presence of aluminum chloride and nitrobenzene gives dash dash dash. Same options are once again is the same. 1-acetyl, let me 1-acetyl naphthalene, 1,2-diacetyl naphthalene, 2-acetyl naphthalene, and all of this. But if you change here the solvent, I am using here is a nitrobenzene as a solvent. As we know that the structure of nitrobenzene, which is a solvent used here, this is the structure of nitrobenzene, and which is a solvent used here. Due to that solvent, what is happening? The products are getting different, which we have got earlier. Example, the acetyl group at one position, but now here exclusively the acetyl group is present at two positions. So that is a question number 19 we have seen over here. So here the right answer would be the second over here. This is the correct answer for this reaction. So this is a question which we have seen over. Now let us move on to the next question. Next question would be, let us see here. Next question would be 19th question, and the questions are like this. The product of reaction is the product of reaction is dash dash dash. The options, the reactions are given here, and as we know that this is a structure drawn over here. Now the catalyst O2 hit it in presence of V2O5 vanadium pentoxide and question mark over here, and the options are given, and options are, A option would be here benzoic acid, second option would be phthalic acid, C option would be phthalic anhydride, and D option would be none of these. Okay, these are the options are given and their questions. The product of reaction is dash dash. Naphthalene is given, air is passes, and the catalyst V2O5. First one is a benzoic acid, phthalic anhydride, and none of these. So here the answer would be, when it is treated, as we know that when naphthalene treated with O2 hit it V2O5, it gives the product like this. The product would be this one, phthalic anhydride. The name of this compound is a phthalic anhydride. And therefore, look at here the options. We know that the structure of benzoic acid would be like this. This is structure of, let me see here, C double bond OH, benzoic acid. Then phthalic acid, this is a structure of phthalic acid, and phthalic acid, the structure of phthalic acid is this one. You can draw here, C double bond OH, 1 at 2 position, here is C double bond OH. This is a structure of phthalic acid. So now phthalic anhydride, this is a structure, and therefore this C would be the correct answer for this reaction. So I think these are the some of the reaction which we were discuss here. So remaining reactions we are going to discuss in our next lecture, means tomorrow's lecture. Till then, have a nice day. Thank you.